Hello class, today we will be working on Chapter 5, Number Theory and the Real Number System. We'll be working on the last section in Chapter 5 today. Chapter 5.7, Arithmetic and Geometric Sequences. Our objectives today are to write terms of an arithmetic sequence, use the formula for the general term of an arithmetic sequence, write terms of a geometric sequence, and use the formula for the general term of a geometric sequence. Those are our objectives. So let's first start by defining sequences. A sequence is a list of numbers that are related to each other by a rule. The numbers in the sequence are called its terms. For example, a Fibonacci sequence term takes the sum of the two previous successive terms, i.e., for example, if A1 is 1 and A2 is 1, then A3 is 1 plus 1, which is 2, A4 is 2 plus 1, which is 3, A5 is 3 plus 2, which is 5, and the next term in the sequence is 3 plus 5, which is 8, and it continues on and on and on, adding the previous two terms to get to the next term. An arithmetic sequence is a sequence in which each term after the first differs from the preceding term by a constant amount. The difference between constant terms is called the common difference of the sequence. So here we have some arithmetic sequences in purple for our example. We have 142, 146, 150, 154, 158. What we can tell here is that the common difference between these numbers in this sequence is 4, because 146 minus 142 is 4. The difference here is 4. To get to the next term, the difference is 4. To get to the next term, the difference is 4. Difference is 4. We're adding 4 to get to the next term. Let's look at this one. We're going from negative 5 to negative 2, from negative 2 to 1, from 1 to 3, from 1 to 4, from 4 to 7. So if we try to find a common difference here, you can take the first terms, 2 minus negative 5. So that's 2, or negative 2 plus 5, which is just 3, right? We have a difference of 3. We're adding 3 here. We're adding 3 here. 1 plus 3 is 4. 4 plus 3 is 7. Our common difference here is 3. Now, our common difference can be negative when we're going down. Our difference between 8 and 3 is 5. So here we are going down 5 though. So we're going down 5. Here we were going in an upward fashion, which is why we use positive numbers. Here we're going down. So we're using a negative number. We're going down by 5 here. From 3 to negative 2, going down 5. Negative 2 to negative 7, going down 5 more. Negative 7 to negative 12, going down 5 more. So let's write the first 6 terms of the arithmetic sequence with the first term 6 and the common difference 4. 6 is the first term, common difference of 4, so we're adding 4. The next term is 10, because 6 plus 4 is 10. Add another 4, that's 14. Add another 4, that's 18. And I do a terrible job of writing my 18s, I apologize. That's 18. 18 plus 4 is 22. 22 plus 4 is 26. So far we got 1, 2, 3, 4, 5, 6 terms. So, as following what we did, first term is 6, second term is 10, so on and so forth, until we get the 6 terms that we want. 6, 10, 14, 18, 22, 26. All we're doing is adding 4. Consider an arithmetic sequence with the first term A1, then the first 6 terms are A1, A1 plus D, A1 plus 2D, A1 plus 3D, A1 plus 4D, A1 plus 5D, all the way from the first term through the 6th term. Using the pattern of the terms results in the following formula for the general term, or the nth term of that arithmetic sequence. The nth term or the general term, of an arithmetic sequence with the first term a1 and common difference d is a sub n equals a1 plus n minus 1 times d. Important formula. Important formula. Might come back to it. Find the 8th term of an arithmetic sequence whose first term is 4 and whose common difference is -7. Now, what we could do here is we could find all 8 terms if we wanted to. We could start with 4, subtract 7, subtract 7, subtract 7, subtract 7 until we get to the 8th term. But the further out we go, the harder that gets, right? So what we're going to do to find the 8th term is we're going to replace n in the formula with 8 and a1 with 4. So to find, and we're going to replace the d with -7 because d is our distance here, or our difference, and that difference is -7. So to find our a to the n, we use the a to the n equals a to the first plus n minus 1 times d. So essentially, all we're doing, if we're doing it by ourselves first, we're doing a to the 8th power. That's the power we want to find. Now we're going to replace that a1 with the a1 they gave us. Okay, the first term they gave us was the 4. Then we are going to add n minus 1. Well, our n is 8. So we're going to do 8 minus 1 here. And our difference here is -7. Boom. Just like that. All those things came from the problem itself. We just had to put them in this formula. Then it's just a matter of simplifying the formula. 8 minus 1. 8 minus 1 gives us a 7. 7 times -7 gives us the -49. 4 plus -49 gives us the 45. So our a to the 8 is -45, which means the 8th term is -45. And we didn't have to go through the headache of finding 6 or 7 other terms to figure out what that 8th term was. We just used the simple formula for arithmetic sequences. Now let's look at geometric sequences. A geometric sequence is a sequence in which each term after the first is obtained by multiplying the preceding term by a fixed non-zero constant. The amount by which we multiply each time is called the common ratio of the sequence. We've got some geometric sequences listed below for examples. The first one is 1, 5, 25, 125, 625, and so on. Can we determine what our multiplying factor here is, what our common ratio is? I think we can, because to get from 1 to 5, you had to multiply by 5. And then to get from 5 to 25, you had to multiply by 5. And then to get from 25 to 125, you had to multiply by 5. So our common ratio here is 5. Let's look at the next one. 4, 8, 16, 32. How did we get from 4 to 8? We multiplied by 2. How did we get from 8 to 16? We multiplied by 2. How did we get from 16 to 32? We multiplied by 2. How did we get from 32 to 64? We multiplied by 2. Our common ratio here is 2. Now, it shows you all you have to do is put your second item over your first to find your common ratio. That's all it did in the first one. 5 over 1, 5 over 1. To find your ratio here, 8 over 4. Our second term is 8. Our first term is 4. We put 8 over 4. Boom. Got 2. We can do the same thing here. Instead of trying to think through what's going on, you could simply just find the ratio by putting the second term over the first term if it's a geometric sequence. So we're putting -12 over 6. That reduces to -2. So I'm multiplying 6 times -2. That's -12. 12 times -2, that's positive 24. 24 times -2, that's -48. 48 times -2, that's positive 96. So our common ratio is -2. This example says write the first 6 terms of the geometric sequence with the first term, 6, and common ratio, 1/3. Ooh. They're not using a whole number. They're using a fraction. We can do it. First term is 6. That's the easy one. They give us the easy one first. Of course they did. Let's try it. I'm going to try to write 6 of these terms. The first one is 6. The second one would be technically 6 over 3, which is equal to 2. The next term would be 2 over 3. Okay, that doesn't reduce. Then that would be 2 over, let's see, 3 times 3 is 9. And that would be 2 over 9 times 3 is 27. Then that would be 2 over 27 times 3. Ooh, it's getting complicated, right? Let's make sure we're doing it right. Second term is 2. We found that. Third term is 2 times 1/3, which is 2/3, and so on. Oh, look at there, we did it. 6, 2, 2/3, 2 ninths, 2 27ths. And if we would have done that 27th and finished our third term, 27 times 3 is 81. And we would have wound up with our sixth term being 2 over 81. Consider a geometric sequence with the first term a1 and common ratio r. Then the first 6 terms are a1, a1r, a1r squared, a1r to the third, a1r to the fourth, a1r to the fifth. So what we see is for a geometric series or sequence, using the pattern of terms results in the following formula for the general term, or the nth term of the geometric sequence. The nth term, or general term of a geometric sequence with the first term a1 and common ratio r is a to the n equals a sub 1 times r raised to the n minus 1. We're going to use this formula. Makes it easier, because a lot of times we don't want to write out the whole sequence. So of course we're going to do an example. Find the 8th term in the geometric series or sequence whose first term is -4 and whose common ratio is 2. Okay, we know the first term. That's our a1. So our a1 is -4 and our common ratio is -2. So r equals that -2. Okay, and then we're trying to find a sub 8 because that is our nth term. So to find the 8th term, a8, we replace n in the formula with 8, a1 with -4, and r with -2. So our general formula, just to remind you, a sub n equals a to the first times r raised to the n minus 1. Okay, our a to the n here is a sub 8. Our a sub 1 here is -4. Our r here is -2. I'm going to keep that in parentheses because that whole thing is going to be raised to an exponent. And then our n minus 1 here, 8 minus 1, which simplifies to 7. So we're looking at a8 equals -4 times -2 raised to the 8 minus 1. 8 minus 1, like I said, does reduce to 7. So this reduces to 7. -2 to the 7th. And remember, that negative is brought up to the 7th as well, but a negative brought up to an odd exponent stays negative. And 2 to the 7th is 128. So this piece right here reduces down to this. And we get -4 times -128, which actually gives us a positive number. So we get a positive 512 as our answer there. That will be our 8th term in our sequence. And that keeps us from having to find 8 terms and do 8 multiplications here to find what that 8th term will be. I hope this was helpful. If you have any questions, please don't hesitate to reach out to me by email and let me know so I can help you. Please go on and attempt to try the homework for this. And please be sure that you are studied up and ready for the entirety of Chapter 5. If you have any questions, let me know. I hope you have a good rest of your day.